Today I will be talking about molecules, following my last video. First, let's talk about the shapes of molecules. We know they are 3D, but have you ever thought about why they are 3D? According to the valence shell electron pair repulsion theory, electrons repel each other and to be as more stable molecule and to minimize the repulsion force between them, they maximize the distance between each electrons. And so molecules are shaped 3D. What are the factors that influence molecule shapes? Well, 12 factors are the number of bonding and lone pairs around the central atom and the number of atoms bonded to the central atom. There are three basic shapes for molecules. One is tetrahedral, one is trigonoplanar, one is linear. For tetrahedral molecules, there are three types of them. One is tetrahedral with 109 bond angles. The second one is trigonopyramid with 109 degrees bond angles. And the third one is bent or V-shaped with 109 degrees bond angles. However, the angles aren't necessarily 109 degrees. This is because going back to the factors that influence the molecule shapes, the number of bonding and lone pairs around the central atom. Well, the lone pairs that around the central atom are closer to the central atom than the bonding pairs, and so the lone pairs they have a larger repulsion force. And because of that, the angles aren't necessarily 109 degrees. Here are some pictures of how it looks like. This angle here is 109 degrees. This angle here is also 109 degrees. This angle here is also 109 degrees. Now let's talk about trigonoplanar. There are two types of them. One is trigonoplanar with 120 bond angles. The second one is bent or V-shaped with 120 bond angles. So this angle here, it's 128 degrees. This angle here, it's also 120 degrees. The last type, the simplest type is linear. It just looks like this. This angle here is 180 degrees. And the three images on the 4th and 5th and 6th slide are cited from this website. Some molecules are polar, some are not. It all depends on if they have polar bonds and how the polar bonds are arranged. If the polar bonds are arranged symmetrically around the central atom, then the molecule is nonpolar. But if it's not arranged symmetrically around the central atom, the molecule would be polar. One characteristic of polar molecules is that if you place them, well, if they are molecules in liquids, and if you place them near something that's charged, they would be deflected. And we know water molecules are polar. The end near O is negative, whereas the end near H is positive, because the electronegativity between oxygen and hydrogen is different. So electrons are put closer to one end. And once solids dissolve in water, alkaline solids dissolved in water. It's just that attraction between water molecules and ionic molecules are greater than water molecules to water molecules, or ionic molecules to ionic molecules. The ionic bonds and the water's intermolecular bonds. Sorry.